All right, welcome to video 2 of the Chapter 9A study guide. We're going to get started with number 19. 19 and 20's directions say, solve for the missing side length, round to the nearest tenth. So both of these are right triangles. That's the first thing I notice. And we have a theorem for right triangles. It's called the Pythagorean Theorem. And so the Pythagorean Theorem says that a squared plus b squared equals c squared. Of course, my c value is always the hypotenuse, and it does not matter which leg is which. So if you wanted to label these, you could. A, B, and C is how I'm going to label these. It would be okay if you flip-flopped your A and your B. Okay, so we would plug this in. Notice that it says round to the nearest tenth. These are, I think, the only two problems on the study guide that say round to the nearest tenth. We're going to do that because these are already in decimal form, so we are not doing simplifying radicals here. And then I believe I did fix this on y'all's study guide before I printed it. I made these approximately because we're rounding. We want to make sure that we show people, hey, this is a rounded answer, unless it's exact. So let's plug that in. That would be 4.3 squared plus 5.7 squared equals x squared. And what I'm going to do is I'm just going to type this entire expression into my calculator, and that is going to give me 50.98, I apologize, 50.98. That is what c squared is. So if I want to know what c is, I'm going to do the inverse operation of squaring, which is taking the square root. What is the square root of 50.98? We're going to round that to about 7.1. Now, I want to pause here. The nearest tenth does not mean the nearest whole number. A few of you got confused on that on the last test. The nearest tenth is one spot after the decimal point. So what you do is you look at the number behind it, and that tells you whether you should round up or whether you should round down. So let me type that in real quick. When I type in the square root of 50.98, oh, goodness, I'm turning this sideways. 50.98. I'm having to use my phone calculator, y'all. I apologize. So when you're looking at that, I just want to make sure I address this now. Whenever you take the square root of 50.98, it's 7.140, and it keeps going. So that 4 behind the 1 tells us to round the 7.1 down. If that 4 was anything higher, like if it was 5, 6, 7, 8, or 9, then you'd round it up to 7.2. So do not round this to 7. This is to the nearest tenth, which is one spot after the decimal. All right, let's do this again. Now I have, I'm looking for a leg. Before I was looking for the hypotenuse. Oh, y'all, we need to pause. Does my answer on number 19 make sense? We always say we've got to check ourselves before we wreck ourselves. Is 7.1, if I put it here, is about 7.1 bigger than both 4.3 and 5.7? Yes, that is a good answer because the hypotenuse should be the longest. So let's start again on number 20. On number 20, my hypotenuse is 15.2, and I'm looking for a leg, which means that my answer should be less than 15.2. If not, I know I did something wrong. So I'm going to do 12.4 squared plus x squared equals 15.2 squared. So, of course, x squared is going to be equal to 15.2 squared minus 12.4 squared. We can type that entire expression into our calculator, and that is going to give me approximately 8.8 when I take the square root. Is that a good answer? Check yourself before you wreck yourself. Yes, 8.8 is less than 15.2. That would be 8.8 meters approximately. Okay, now the next set of directions is different, so I'm going to slow down here. It says solve for the missing side length again, but now instead of saying round to the nearest tenth, it says leave in simplest radical form, so you're not going to have any decimals here. This is just like the beginning section. So again, good old Pythagorean theorem. We're going to label these A, B, and C. So I'm looking for a leg. We know that that leg should be less than 12. So a squared plus b squared equals c squared. We'd go 3 squared plus x squared equals 12 squared. We have kind of started working on doing the Pythagorean theorem faster, so typing this entire expression into our calculator. That is going to give me the square root of 135. Is there a perfect square that lives in the square root of 135? That is a factor. There is. I believe that is root 9, root 15. Root 9, root 15. Why does that help me? Because the square root of 9 is 3, and so that'd be 3 root 15 in simplest radical form. This answer is exact. It is not rounded, so x is exactly equal to 3 root 15. Now you could type this in your calculator simply to see if it is less than 12, which it is. Okay? Okay, sorry, y'all. I apologize. The cough will not go away. All right, let's go again. We have A, B, and C. And so I'm going to do 10 squared plus 4 squared is equal to x squared. Now I know that whatever I get should be bigger than 10 and bigger than 4. So I'm going to type that entire expression in my calculator. We end up getting x squared is equal to 116. So x is going to be the square root of 116. That does simplify to root 4, root 29. Root 4, root 29 becomes 2, root 29. So what is my answer in simplest radical form? X is going to be equal to 2, root 29 exactly. You could type that in just to see what it is approximately as a decimal and make sure that it is bigger than 10 and make sure that it is bigger than 4. So our directions are the exact same for number 23 and 24. We just rewrote those directions so that you would not forget to leave them in simplest radical form, not the decimal answers. And so I'm going to be labeling them. There's A, there's B, there's C. It's a right angle. And there's my hypotenuse. So x squared plus 9 squared equals 10 squared. So, of course, whenever we're doing this quickly, we know to move that 9 squared over, and then we can type that whole thing in. So x squared is going to be equal to 19, which means that x is going to be equal to the square root of 19. X is going to be equal to root 19. So what you're going to do is you're going to go through and you're going to see, does that simplify at all? Are there any perfect square factors in the square root of 19? So let's find out. We'd go through, we would see that there are no perfect square factors. So I'm going to leave my answer as the square root of 19. Okay? All right. So square root of 19 is the final answer on that one. I think my Apple Pencil has disconnected. Hold on one second, y'all. Will it let me write? It will not. So I'm going to pause here and I'll make another video.